So in this video, we're going to talk about cylindrical shells about the y-axis, okay? And so we know that the volume with respect to y is given from a to b of 2 pi y times f of y dy. Okay, so that's the general formula. And so I have this problem here. And it says find the volume of the solid by the regions, enclosed by y is equal to the square root of x. X is equal to 0 and x is equal to 1 about the x-axis. So we know that we are revolving around the x-axis. Okay, well, so that's nice to know. So that means that we're integrating with respect to y. Now, if I look at the graph here, I know this is y is equal to x, the square root of x. And we know this is where x is equal to 0. And we know this is where x is equal to 1. Okay. Now, we got to be very careful here. It says about the y-axis. And so we're integrating everything with respect to y. My function is with respect to x. And so I got to change that. So if I take y and set that it's equal to the x, if I take this, well, if I square this and I square this, then I get x to be y squared. Okay, and so we got to be very careful. And so now that my function is in terms of y, well, now I have x is equal to y squared. Okay, because we're integrating with respect to y because we're rotating about the x-axis. And so if I'm looking at this, well, I have x is equal to 0 and x is equal to 1. So those are not my limits of integration with respect to x. Okay, those are not my limits of integration. So what I have to do is set y squared equal to 0 and y squared equal to 1. And if I set those equal to 0, so if I set y squared is equal to 0, I get that y is equal to 0. And if I set y squared is equal to 1, if I take the square root of this and I take the square root of 1, y is also equal to 1. Okay, so that's the whole idea. So now that I have my limits of integration with respect to y and my function, I can just go ahead and plug in. So the volume now will be given by the integral from 0 to 1 of 2 pi y, 2 pi y. And what's my function? My function is y. Well, no, gotta be very careful here. What's my function? Well, if you're walking along the y-axis, since we're rotating about the x, well, look, as I walk, my upper function is actually given by 1. So x is equal to 1. Okay, or y is equal to 1 in this case. So my upper function is given by x is equal to 1, this line 1 here. And so if I look at this will actually be my upper function, which is 1. And I subtract that from, well, the lower function happens to be y squared. So this is y squared. We attach our dy under. Okay. So we know that 2 pi is a constant, so we'll just go ahead and factor it out. So we know this is given by 2 pi times the integral from 0 to 1 of y. And I'm going to just distribute my y. So this becomes y minus y cubed dy. And as I take my integral, this becomes 2 pi multiplied by y squared over 2 minus y to the 4th over 4, all integrated from 0 to 1. Again, the second part I do not have to worry about because it's 0. So this now becomes 2 pi. This becomes 2 pi times 1/2 minus 1/4. Okay. So that becomes 2 pi 1/2 minus 1/4. Okay. So what do we do next? So if we take 1/2, okay, if we take 1/2 and minus that from 1/4, what do we get? Well, we get 1/4. Okay. If I take 1/2 and minus that from 1/4, we get 1/4. So this becomes 2 pi times 1 over 4. And that's simplified. So that's 1. That's 2. So this becomes pi over 2. And that will be your answer. So be very careful about the x and y axis of cylindrical shell, because you got to remember they're opposite. If we're rotating about the x, we integrate with respect to y.